All right, we'll begin. Happy Friday, everybody. I hope your first week has gone well and getting all settled in with your classes. And today we are going to I'm going to try to cover as much of Chapter 2 as possible. Okay, so Chapter 2 is all about summarizing and describing variables with graphic displays. Okay. And so we'll first start talking about graphic displays for numeric variables. All right, let me have you guys settle down back there. Okay, so as far as graphic displays for numeric variables go, our first example will be the dot plot. Okay, a dot plot is very simple. It's basically a number line with dots for where the data is. So dot plot is a number line with dots for each data point. Okay, and so, just imagine, just for a simple example, let's say a family has 5 children. I don't know what just happened there. Okay, so a family has 5 children, and we'll say their ages in years are 1, 1, 2, 4, and 15. Okay, and so to create a dot plot, we start with a number line. All right, and then and we just put dots for each data point. So we have 2 people who are 1 year old, 2, 4, and 15. Okay, and so so at a simple level, the dot plot gives us a sense of where our data is and how spread apart they are. Okay, and so let's say here I'm just making there's just another arbitrary dot plot for some data I'm making up here. Okay, and maybe we find okay, and so maybe we ask several couples, between ages 20 and, I don't know, we'll say 25 to 35, and we asked, how many children do you have, right? So we'll say couples aged 25 to 35, how many children? All right, and maybe these are the answers that we got. Okay. All right, and so we can get a sense that, okay, most of these couples have 0, 1, 2, or 3 kids, but a few have more than that, and we have one couple that has 8 kids. Okay. We can so this would be a dot plot, and we can express. Whoa! Was not expecting that. Give me a. I apologize. Startled me as well. We can, instead of a dot plot, so with a dot plot we have dots, and dot plots are probably best for smaller data sets. Okay, so this is a dot plot. Okay, better for smaller data sets. Okay, we could express the same information with a histogram. Okay, and so for the histogram, I'm going to just kind of use the we'll come over here. Oops. And with a histogram, we will use bars, and on the this axis over here, we will have how the frequency of these values. So I've got 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so all we do is we say, okay, well, there's 1, 2, 3, 4, 5. So this bar starting at 0 goes to 5, and then the next one goes up to 7. And then the next one, there's also 5. And the next one has 3. And 2, 1, and then 1 at 8. And so this is a histogram. And it represents the same data as the dot plot. Okay. The advantage with the histogram is, for a dot plot, let's say we asked a different question, such as I don't know what the we ask, let's say we go to a bunch of different schools around the nation, and we say, how many students attend your school? Okay, and let's say these are like elementary through high school. So so K through 12, we go through a bunch of schools, and some places say, oh, we have 674 students in our student body, and then another place says we have 4,253, and another place says, oh, we have 158, or something like this. Okay, so if we recorded all of these different values for how many students attend a school, with a dot plot, I would need to have a different tick mark on my number line, and I would put a dot for each value that I see. okay? And probably if one school has 4,238 students, I don't know, I might come across with another school that has also exactly 4,238 students, but chances are is I probably won't find another school with that exact same amount of students, but maybe another school have 4,250 students or something like that, okay? With a dot plot, you know, every spot on the every tick mark is a separate number, and so you're going to have just one dot at 4,238 and one dot at 4,250, okay? And so you're going to have kind of all these numbers all over the place and just little like one dot here and there, okay? Maybe a few spots will have a few dots stacked up. With a histogram, what we can do is we can bin certain values together, okay? Over here we have just one, each bar represents one value, but what we can do with a histogram is we can have a bar that represents, you know, values between 0 and 200, another bar that represents between 201 and 400 students, another bar for 401 to 600 students, so on and so forth, so that, you know, as we look at all of these different sized schools, you know, the school that has 4,238 and the school that has 4,250, they will get put together in the same bin. Does that kind of make sense? Okay, so with histograms, you know, histograms are better for larger data sets because we can bin our values together. Okay, and so what we will do is we can create a bin. And so in this case, we can create a bin that goes 0 up to, but not including 3. So this is a bin from 0 up to, but not including 3, okay? And so if we're dealing with situations where we only have whole number answers, this means the values 0, 1, and 2. But you know, if we had a situation where we had decimal points and we said, you know, how much money do you have in your pocket right now? This would include up through 0 to $2.99 type of thing. Okay, 0 but up to and not including 3. And then our next bin will go what? 3 up to but not including 6, and then 6 up to but not including 9. Okay, and then over here we will have our frequency, and we say, okay, 0, 1, and 2, how many do I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I've got 17 values there. Between 3 and 6, I got 1, 2, 3, 4, 5, 6, I'm sorry, 3, 4, and 5, I have 6 values, and then between 6, 7, and 8, I have 1. Okay, and so therefore, my histogram here will look something like this. I've got 17. This is 0, 3, 6, 9. And I've got 1, 2, 3, 4, 5. So over here, this goes to 6. And this one is at 1. Okay, so this is my histogram with bins. So it's the same data as this. It looks very different because we've binned some of these values together. Okay, so you know, if our values are spread out all over the place, binning is useful. So for example, kind of the school populations. We can create a bin for 0 to, I'll just say 0 to 400, 0 to 499, 500 to 999, 1,000 to 1499, etc., etc. Okay, and we would bin all of these schools together, something like that. Okay, are there any questions on this? This is all okay? Yes. Yeah, your bin width should be the same across the board. Okay, and yeah, when we draw a histogram, traditionally this bar that starts over here is 0 up to, but not including 3. Okay, and that's why over here, even though each bar represents only a single value, this bar technically is 0 up to, but not including 1. Okay, and if it's a decimal value, then it might make sense that that's everything from 0 to like 0.999. But when you only have whole number answers, 0 up to and not including 1 is just the value 0. Okay, so sometimes you might feel like I should make the bar centered at 0, but that's not what we do. We draw a bar that starts at 0 and goes up to, but not including 1. So that's what we have there. The textbook mentions something called a stem plot and stem and leaf plot. I'm just going to leave it to your reading. I'll say, read about stem plots. Okay, that's okay. We have other. Let's talk about. Sometimes we want to describe our data set by describing the distribution. Okay, so this is just a separate thing. Read about stem plots. Okay. Sometimes we may try to describe the distribution of our data. Or we might just say, describe the distribution. Okay? And when we use the word distribution, what we're referring to is the idea of how are the values in our data set, how are they distributed along the number line. How are the values in the data set distributed on the number line? Are they all kind of spread out across the number line? Are they all clumped together in one spot? Are they, do some appear over here? Do some appear over here on the number line? This is kind of the question that we have. Okay, how are the values distributed on the number line? And so, a lot of times we try to get an idea of what our data look like by creating a histogram. Okay, so we probably have to create some kind of diagram first. Like a histogram first. And so, just imagine we have a histogram that looks kind of like this. Okay, and it's a little tedious for me to have to draw all of these bars out every single time. So we may say, you know what, instead, I'm just going to make my life a little bit easier and just say this shape can be represented by this curve. Okay, so we'll say, so here we have the histogram, and we will just have a representative curve over here. And so when we look at a curve like this, we might want to describe, you know, the shape of this curve, the shape of the data that this curve represents. And the terms here we would use would be, we would describe this as unimodal. So the curve and the histogram represent the same data. Keep that in mind, okay? We would say our data is unimodal. Okay? So uni comes from represents one, and modal represents kind of this idea of the mode. So I'm assuming, you know, at some point in your high school education, you learned about the three different averages: the mean, the median, and the mode, right? And the mode was what? The value that appeared most frequently. And so in this case, when we're talking about unimodal, that means there is one range of values that appears most frequently, okay? One range or one area of values are most frequent. Okay, so the mode here is most frequent. These values right here, or correspondingly over here, these values are most frequent. Values here are most frequent, and that's kind of there's only one range where the values are most frequent. I should probably spread this out a tiny bit. So our data is unimodal, one range of values are most frequent. And then we would also say the data is symmetric. Our data symmetric. The idea being that, you know, we have some high values, this would be the areas out here, this is considered the tail. And this down here is also the tail. And the idea with a symmetric distribution is that your tail for large values, which are on that side, and the tail for low values, they appear with about the same frequency. Okay, so values that are high, you've got about the same number of values that are on the high side as you do values on the low side. Okay, so our data is symmetric, so we have, you know, approximately the same frequency of high values as we do low values. The same frequency of high values as I guess the frequency for low values. Okay, and so that's kind of the idea of being symmetric. And so, you know, maybe an examples of symmetric distributions. be height. And IQ scores, also SAT scores, are designed to be symmetric in that most people are kind of in this average height or average SAT score or average IQ score, whatever you want to say. Some people have very high heights or high SAT or high IQ scores. Some people have lower heights, or some people have low IQ scores or low SAT scores. And we expect approximately same number of people that are very high, or I guess in your case, same number of people that are very high as we do the people who are very low. Okay, we expect those things, the extreme high and the extreme low, to appear in approximately the same frequency. We expect extreme high and extreme low appear with similar frequency. Okay, so that would be symmetric, and if I can continue on, we can have a curve, maybe that that looks something like this. Okay? And we would say this thing is, well, this is still unimodal, okay? Meaning there's only one spot that has a peak, but we would say this is right skewed. Okay? And over here, this is our tail. The tail is on the right, okay? Or if you want to remember it and say, like, if I had to, if we were going to use this to skewer something, skewer some meat or whatever, you would use the right side, okay? The right side has the pointy end, okay? And so the idea here for right skewed values is that kind of most of our data is kind of in this zone, right? Most values are here. We have some values are very high. But if we go in the opposite direction, we have no values that are very extremely low. So an example of data that is right skewed is income. Okay. So as far as income goes, if we're talking about different households across the nation, most households will say make between $0 and $150,000, okay, annual salary or annual household income, okay. And just for simplicity, this is not the case, but just for simplicity, let's say the average is 100,000. It's much lower than that, but just for simplicity, we'll say the average income is 100,000. Okay. Are there households that have an income of $1 million a year? Yeah, so $1 million for you guys would be way on the right. Okay, so if we say average is something around here, and that's 100,000, a million is 900,000 more than average. Okay. What happens if we go 900,000 below average? That takes me to negative 800,000. Okay, can any household have negative income? No, okay? As far as being paid a wage, you cannot have negative income. Perhaps your household got into some, I don't know, debt or something, and things are going wrong. But as far as being paid and things like that, you can't have a negative wage. And so what your distribution will look like is that you're going to have kind of a hard cap at of 0, so that your household can't have a negative income, and the bulk of people will be over here, and yes, you'll have some values that are extremely high, okay, income. So let me just start off. We'll say most will have income between 0 and 150,000. Okay, but some will have income of 1 million or more. But no one will have income lower than 0. So you can't go that way, right? And on the other hand, so if that's right skewed, what would we say this shape is? So this would be left skewed. Okay, left skewed. Maybe an example would be scores on an easy test. Okay, with an easy test, maybe a lot of people are getting 85, 90, close to 100. Okay, but you're not going to have anybody going over 100%. But even though it's an easy test, you might have some people getting 40% or 35% or something like that. Okay, and so this would be left skewed. Question?
If the peak were 0, let's say it's not income, if the peak was 0, would that still be right skewed?
Yeah. The right skewed just refers to the shape that you have some values that are extremely high and no values that are extremely low. Okay, and left skewed is just the opposite. Kind of the bulk is right here. You have some values that are extremely low, but no values that are extremely high. Okay, and so that would be left skewed. These are unimodal. What would this be called? This would be bimodal. Okay, this would have kind of 2 peaks, two ranges that are most common, something like that. Generally with a gap in between, an area in between that is less common. All right, is this okay? The idea of describing the shape of a distribution of data. This is numeric data. With numeric data, we can create something like a histogram and then describe the shape of that histogram. Okay, these curves that I drew. These are kind of like archetypes of what left skewed and right skewed look like. When you look at actual data, it will never be as smooth and clear cut as this. All right, so that's graphic displays for numeric data. Let's talk about displays and summaries for categorical data. Okay, and so perhaps we want to, let's say we have a data table. We've gathered data on a categorical variable. Okay, so we gather okay, and as far as the categorical variable goes, so let's say we went to the parking lot, and we just we look at each car, and we say, is this car an American car, or is it from Europe, or is it from Asia? I don't know. Are there other? We're going to say where the headquarters of that company is, right? So I know there's like Nissan plants in the U.S., but we're going to just say if it says Nissan, we're going to say that's from Asia, from Japan. Okay. So we'll say kind of the origin or the origin of the vehicle. Okay. So we'll say where the car and its origin. Okay. All right. So car one, let's say, is an American car. And then car 2, let's say, is I'll just put Asia, because in Asia you have Korean manufacturers and Japanese manufacturers. We'll just group them together. Car 3 we'll say is Europe. Okay, so that would be all the German cars, but British and French, Italian cars, things like that. Okay. And I don't know, we go through, maybe car 4 is another European car, so on and so forth. And let's say we gather data on 200 vehicles. So we will have 200 rows, okay? And I guess we've only collected one variable here. So we just have one variable other than, our listing. But we can, you probably, if you just gathered this data and you just handed over to your boss, here's a list of 200 cars and their origins, nobody's going to want to have to go through all 200 rows. Okay, so we want to summarize this. Okay, so we're going to summarize the 200 rows. Okay, into a frequency table. And so with the frequency table, what we have is we take this thing, the origin, and we measure its frequency. Okay, and so the origin, we will say there's USA, Asia, Europe, and then we'll have an other, just in case we come across a vehicle that doesn't fit any of the other categories. All right, and so with 200, I don't know, maybe we'll say 52 and I don't know, 95. Now I need to do some math here. 52 and 95 is what? 147. So we'll say 50, 51, and 2. Okay. All right, so this is what we have. 52, 95, 51, and 2 for a total of 200 vehicles. All right, so this is our frequency table, and then we would create a bar chart. Now let's start off at 0. Did I mess something up? 10, 20, 30, 40, 50, 60, 70, 80, 90. This is 100 right here. All right, and then so for USA, we would go up to 52. And Asia would go up to, I'm just making stuff up here, 95, Europe. Right there. and other something like that. Okay, and so here's our bar chart. So the bar chart requires that we create a frequency table, and then based on the frequency table, we just create bars representing the heights there. Okay. With a bar chart though, what we can do is you can rearrange the bars and have still a legitimate graph here. Okay. So I can so somebody else can say, you know what, I want to rearrange the bars to go in this order. And you can do that. That's allowed. Okay, so we can rearrange the bars if you want to sort them from tallest to shortest. That's fine. Okay, so we can rearrange the bars because the ordering of the bars is arbitrary. You can't, if we compare this to a histogram, okay, with a histogram, we cannot rearrange these bars. The bars are associated with the number line, and you can't just say, well, today I feel like putting the number 7 in between the numbers 3 and 4. Okay, we can't do that. With a categorical variable, if you want to say, you know, I want to put Europe over here and Asia over here and the USA over in this spot, you can do that. Okay, you can arrange them in alphabetical order. You can arrange them based on, you know, certain preferences or things. You know, there's no rules as far as the arrangement of the bars. Also with bar charts, generally we leave little gaps between the bars, and with a histogram, there are no gaps between the bars. That's more of a stylistic thing. It's not as critical, but generally that's another distinguishing feature. Okay, let's talk about variation, this concept of variation in categorical variables. And the idea with variation is, are the values in our data set, are they very different from each other? If they're very different, then that means we have high variation, okay? So high variation means the values in our data set are very different from each other. Okay. Low variation, on the other hand, means that the values in our data set are very similar to each other, okay? Are the same or similar to each other. Okay. Let's say you went to a field, okay? And in this field they have different flowers, and the flowers come in 3 colors, okay? They can have red flowers, pink flowers, and white flowers. Red, pink, and white, okay? And so we'll have field A. These are summary tables, okay? So we have the color of the flower and the frequency. All right, and so we'll say in field A, we have 33 red flowers 34 pink flowers and 32 white flowers. Okay. Over in field B, we'll have the color and the frequency, red, pink, white. We'll say there are 90 red flowers, 15 pink flowers, and 3 white flowers. Okay, so this will be what we have. And so we create bar charts here. Okay, so with the bar chart over here, we've got it's going to look something like this, and this, and this. Okay, so this is red, pink, white. All right, over here, we got red, I don't know why I'm saying this. None of my buttons work anymore.